Hi guys, Paul from RoboFlow here. Today I want to talk to you about how to train SegFormer on a custom dataset using the Pytorch Lightning library. So as you might have guessed, the first thing we need is a custom dataset to train on. You might have your own and you can bring that. If you don't have a semantic segmentation dataset type, you can find one at RoboFlow Universe. RoboFlow Universe hosts thousands of public datasets for you to use for free. It also hosts datasets, so if you have one and you're looking for a place to host it, to have some convenient format transforms, share it with your friends, share it with your colleagues, RoboFlow Universe is the place to do that. So I'm going to go ahead and search here for semantic segmentation project types. And that's a keyword that RoboFlow knows, and so you can see it's gone ahead and brought up all the semantic segmentation project types it knows about. This balloons one is one that I've uploaded. It's a public balloons dataset, kind of used as an example for training tutorials on semantic segmentation. So let's go ahead and open that one. You can open the sidebar here, but you can also go to the full project page here. This is a public page. The first thing you'll see is a README about the dataset. You'll also see a button to download this dataset. Before we do that, let's see what versions are available. You'll find the versions on this dataset drawer over here. You can see there's 3 versions. The first version is the one we're going to use today for the sake of time. It's a small version because it's just the raw images with no OGs, except for a little bit of pre-processing. We'll auto-orient it, and we're also going to resize it to 512 by 512. Because that's the size of our input size during training. So to do that, to download this dataset, we're going to click this download button. Choose your format. In this case, it's already the format that we want, which are semantic segmentation masks. And then you can choose to download the zip to your computer or show us some download code. Now let's do that since we'll be working in a Jupyter notebook. We're already on the Jupyter notebook tab, and this shows us a nice easy way to use the RoboFlow pip package to download this particular version of this particular data set. The thing that's obfuscated here is your API key, but if you copy this, it will still copy correctly. So when you're going to run this tutorial on your own, copy this code snippet from this page and carry it with you to the collab. Let's go to the collab now. Here's our collab of how to train SegFormer on custom data. It starts with an intro to tell you about this collab, but the first meaningful piece of code is installing our dependencies. I've already done that for sake of time, but what we're installing is the Pytorch Lightning, which is going to be our training framework. We're installing transformers from Hugging Face as well as datasets. That's going to bring SegFormer architecture in our metrics, and also the RoboFlow pip package, which is going to help us download our dataset. So we import all of our dependencies here, and then we go ahead and download our RoboFlow dataset. I've gone ahead and done that so that I'm not sharing my API key here, but this is where you paste that code snippet and run it. It'll show you your progress as it downloads images, and then you can look on disk and you'll see that it has created a folder and put the dataset that you specified, dataset version that you specified in that folder. So the first thing we want to define is the semantic segmentation dataset class we're inheriting from Pytorch dataset class, and this just defines how the training routine should read the data off the disk and what it should do to it before it serves it to the network for processing. The key things here define where the dataset is on the disk. We're also defining which class names correspond to which values in the segmentation masks, things like that. A method to determine how many samples this dataset, and then most importantly is this get item method that determines exactly how the data is read off the disk and what happens to it before it goes to the training code. So let's go ahead and run that. It should run very quickly. We're just defining a class here. So the next class we want to define is the SegFormer Fine Tuner class that inherits from the Pytorch Lightning module. This is the meat of the code. This is what tells Pytorch Lightning exactly how to run this model, how to initialize this model, and what metrics we want to run on it. So here in this init function is where we're instantiating the SegFormer from semantic segmentation model. We're going to use pre-trained weights from the 8020K dataset. 512 by 512 is the size we're looking for there. We're also defining our metrics, which is mean IOU. This particular function also comes along with mean accuracy, and the last metric we'll use is loss. And the loss is actually calculated. That's internal to this particular implementation of the SegFormer architecture here. And the training step defines exactly how to calculate loss, and we're going to return the loss, and we're also going to calculate some metrics. So this will run on every step of training on a particular batch. That's pretty self-explanatory, but here we're running our inputs through the model. We're getting our loss. SegFormer, the output is half the resolution of the input, or a quarter, depending on how you look at it. But if our input's 512 by 512, our output's going to be 256 by 256. So if you want a full-size mask, you have to upsample it, and then you do the argmax because the number of channels of the output is equal to the number of classes on your data set. So if you do argmax, that will create a single channel output where each pixel value is 1 through n being the number of classes you have. And that will be a more useful format for kind of your pixel level classification problem here. You can see we're using our metrics method and very similar methods for the validation step and the test step here. As we go down, one important thing to note is we are using the built-in Pytorch Lightning logger class. So you can see we're making calls to self.log here for our various metrics. That is going to come in later when we want to look at our actual performance. So go ahead and run that. Next thing, we're going to instantiate all the classes we just defined. So first we're going to get our feature extractor. This is responsible for doing all the pre-processing before we actually run data through SegFormer. We're passing the particular configuration that we want to use here. So this tells us what size we want to use and what normalization we're going to use. A particular thing to note here, we're going to actually do a pretty small run today just for the sake of time, but this is the size of data that you actually want your network to be trained on. So nominally you would leave this at 512 by 512 to match our pre-trained weights, but we're going to make it smaller so that our network runs a little faster during training. We're defining our data sets and our data loaders. Another thing to note here is you're going to want to change the parameters of the data loader based on the hardware you're running on. And there we have our instantiation of our SegFormer fine tuner. So we're pretty close here. The last couple things, we just have a couple training items we want to go over and we want to set up before training starts. So we're going to do some early stopping based on validation with patients of 10. So if validation doesn't improve for 10 epochs, then we'll go ahead and stop training, ensure we don't overfit. We also have a checkpoint callback so that we're always saving the best model as we see them come out based on validation loss. And then we instantiate our Pytorch Lightning trainer. We're using 1 GPU here because we're on Colab. We'll let it run for 500 epochs at the most, if it's not early stopped by the callback. And we're going to do validation metrics calculations once an epoch, so once per length of the trained data loader. And then we'll go ahead and run that, and we'll watch it start up here. For the sake of time, I'm going to stop this, and I'm going to jump over to a tab that I have already run this training on. So we're over here. You can see it made it to epoch 98 before it was early stopped. So that means 88 was the last time that loss improved, but it early stopped here, and we had a checkpoint that was saving the best model. So nice thing about Pytorch Lightning is the default logger is a TensorBoard logger. So if you are in a Jupyter notebook, you can just run these 2 simple lines of code to bring up a TensorBoard session, and it will find the logs in the default location, and it will open a TensorBoard for you with those logs. So you can see we've got access to a few different logs here. Let's look at our validation loss because that's the thing we were early stopping on. That's a great looking loss curve. You can see it comes down, kind of has some decay to it, and it kind of reaches a steady state. If you wanted to see more of this chart, you wanted to let training go a little longer, you can increase that patience value, and that'll let the network train a little bit longer. And you can kind of really see that this is not likely to improve much more than it already is. Another nice thing about Pytorch Lightning is that testing is a one-liner. So we're just going to take our trainer object, our SegFormer fine tuner trainer object, and run test. And we're telling it to use the best checkpoint for testing, and we get our metrics. Tells us the loss, which you want to just make sure that this isn't wildly different than your training or validation losses. Also tells us the mean accuracy from that run and the mean IOU. These are great numbers for comparing from one run to another, but they're not super meaningful to visualize or anything like that. So let's go ahead and visualize this, the output of our network on some test data. So this is what it looks like, the model output here on the left, and the ground truth label here on the right. So not too great on the first sample, but you can see it's obviously trying for these other samples. Again, we're using a very small data set. We're on small hardware. Our batch size is pretty small, so we're not expected to do any miracles here, but it's doing a pretty good job considering the circumstances here. So that's it. That wraps up training SegFormer on a custom data set. If you'd like to read more about custom training or the latest computer vision news, go to the RoboFlow blog, blog.roboflow.com. If you want to see more of these videos with how to train tutorials or the latest research on computer vision, like and subscribe. Thanks for watching.